A man stands knee-deep in swamp water in central New York. The year is 1819. His name is Patrick Donnelly. He arrived from County Mayo 6 months ago with nothing but a shovel and the address of a contractor. This morning, 3 of the men he shared a tent with did not wake up. He picks up his shovel anyway. What he digs changes the history of settlement in America. This is the story of the construction of the Erie Canal. In 1817, the American interior was economically almost completely cut off from the rest of the world. To move a ton of freight overland from Buffalo to New York City cost $100 and took weeks. Farmers in Ohio and western New York were sitting on some of the richest soil on the continent and could not sell what they grew. The solution, as Governor DeWitt Clinton of New York saw it, was a canal, not a short one. A canal 363 miles long from the Hudson River at Albany to Lake Erie at Buffalo, crossing forests, swamps, and a 570-foot change in elevation. Thomas Jefferson called the idea little short of madness. Clinton's opponents called it Clinton's folly. Clinton called it necessary. What made it possible was not machines or professional engineers. There were almost none of those in America at the time. What made it possible was men like Patrick Donnelly. Donnelly was one of thousands of Irish immigrants who arrived in New York Harbor and were hired almost immediately onto canal work gangs. Wages ran between 50 cents and $1 a day. Contractors also issued a daily ration of whiskey, which tells you something about the conditions men were expected to endure. Construction began on July 4, 1817, but before digging could begin, the area had to be cleared. Dense forest covered most of the route. Work crews threw ropes over the highest branches and used a central winch pulled by oxen to bring trees down. It was faster than axe work alone, and it had to be. The canal needed to cover more than a mile of new ground every single week. Stumps were the next problem. To remove them efficiently, workers devised a large-wheeled machine, essentially a rolling frame with chains, that used the mechanical advantage of oxen on a central drum to rip stumps clean from the ground. It was improvised engineering, built from necessity. Before it existed, clearing a single acre could take days. Once the trees and stumps were gone, the real digging began. The canal's cross-section had to be exact, 40 feet wide at the surface, 4 feet deep. Consistent dimensions help control erosion, leakage, and navigability. Deviate from those dimensions, and the water pressure would behave differently along every section of bank. A poorly shaped channel erodes faster. An eroding channel silts. A silted canal is useless. Every foot of those 363 miles was dug by hand. Animal-drawn scrapers and plows, blasting and mechanical equipment aided the work. 9,000 men worked the line at any given time. The canal needed 83 locks to manage its elevation changes, stone chambers that raised or lowered boats as the terrain demanded. Stone locks required hydraulic cement. The only known sources were in Europe, and importing it would have made the project financially impossible. Then, in 1818, workers struck an unusual vein of limestone near the middle section of the canal. A young engineer named Canvas White, who had spent a year walking English canals at his own expense, recognized it immediately. When calcinated, ground to powder, and mixed with water and sand, this stone hardened underwater. It set in conditions that would dissolve ordinary mortar within a season. White patented the formula. More than 500,000 bushels of it were used in the construction. Each lock chamber had to be built to hold not just the weight of water, but the constant pressure of loaded boats pressing against its walls, day after day. The tolerances were unforgiving. A gap of a few inches in the wrong place, and the structure would slowly fail from within. If the cement had not been found, the locks would have crumbled within years. The canal would have failed before it was finished. Summer 1819, the Montezuma Marsh. The mosquitoes came first, then the fever. The men called it Genesee fever. It was malaria. Within weeks, over 1,000 workers were dead or dying. Several contractors abandoned their sections entirely. Construction halted. When the marsh froze that winter, The surviving men went back in. No monument marks where those men were buried. The graves have never been found. At the time, the discovery of mastodon bones in the same swamp received more coverage in the local newspapers than the deaths of the workers. At Lockport, near the western end of the canal, the terrain presented its final obstacle, the Niagara Escarpment, a wall of solid rock rising 60 feet above the canal line. To carry boats over it, engineers designed a staircase of 5 paired locks, each raising or lowering vessels 12 feet. The rock was cut with black powder charges drilled by hand. It took 2 years. The precision required was exact. The lock chambers had to be level to within fractions of an inch. A poorly placed stone could allow water to undermine the structure from within. Not in days. Over years. Long after the men who built it had moved on. By the early 1820s, the men building the Erie Canal had become, without intending to, the first generation of American civil engineers. Benjamin Wright and James Geddes, the canal's 2 chief engineers, both lawyers by trade, had trained themselves on the job. Canvas White's hydraulic cement formula would be used in infrastructure projects across the country for decades. Very little of this knowledge had existed in America before 1817. Most of it was invented, tested and refined in a muddy trench between Albany and Buffalo. On November 4th, 1825, Governor DeWitt Clinton stood on the deck of the Seneca Chief in New York Harbor and poured a keg of Lake Erie water into the Atlantic Ocean. He called it the Wedding of the Waters. The canal was open. The canal had taken 8 years and 9,000 workers. It had been built without professional engineers, without industrial machinery, and without a single federal dollar. Within 9 years of opening, the canal's tolls had repaid its entire construction cost of $7 million. The Erie Canal did not merely move goods. It moved people. It moved possibility. Within a generation, New York City's population quadrupled. Buffalo, Rochester, and Syracuse grew from frontier outposts into functioning cities. The canal carried more westbound immigrants than any other route across the Appalachians. Before it opened, it was cheaper to ship goods from Liverpool to New York than to haul them overland from Illinois. That fact described a barrier. The canal removed it. By the 1850s, the railroads had arrived, faster, cheaper, and indifferent to winter. Canal traffic declined. The era of shovel and wheelbarrow and black powder was over. The engineers trained on the Erie Canal's banks went on to build the railroads that replaced it. The knowledge did not disappear. It migrated. What Patrick Donnelly dug with a shovel in a swamp now carries boats through the heart of New York State, 200 years later, still holding water. These systems shaped the world quietly. If you'd like to see more of them preserved, consider subscribing. And tell us, which forgotten craft or project should we document next?